Hello, this is the second video on magnets. This was taught in class 6. In this video, we will learn about magnetic induction, magnetization, and magnetic field. So what is induction? When a piece of iron is attached to a magnet, we know that the magnet attracts the piece of iron. So the piece of iron sticks to the magnet. So during that time, when the piece of iron is sticking to the magnet, the piece of iron also behaves as a magnet. So temporarily, a piece of iron behaves like a magnet because it is under the influence of another magnet. So this is called magnetization by induction. Okay. So, and when the piece of iron is pulled away from the magnet, it is no longer a magnet. A strong magnet which is close to a piece of iron induces the piece of iron to behave like a magnet temporarily for as long as it is in contact or close to. So what do we mean by induce? To induce means to lead someone to do something, to make someone do something. So you can induce a child to do the homework by offering it some sweets. So that is induction. Okay, so a piece of iron becomes a temporary magnet through induction. Here I have some paper pins and a magnet. Okay, the paper pins are not magnetic. They are not picking up the other pins. Paper pins are not magnetic. They're made of iron, but. So when I pick up the pin with the magnet, now the pin behaves like a magnet. It is picking up the second pin. Okay, so this is induced magnetism. So the pins are picking up other pins. They're behaving like magnets because of induction. So we use induced magnetism in this kind of paper clip holders. So this hole here is a ring magnet. So the paper clips stick to that ring magnet and they behave like magnets and they will pull up the clips which are at the bottom. Okay. So the next thing we need to know about magnets is that you can make permanent magnets also. So what we saw just before this is a induced magnet, which is temporary. So you can make a piece of iron into a permanent magnet also. So when a piece of iron is, so how do you do that? Okay, so we saw how we can make it a temporary magnet by bringing it close to a magnet. We can bring the piece of iron close to the magnet and make it behave like a magnet. But we can make it into a permanent magnet by rubbing it with a strong magnet repeatedly in the same direction. So this is an iron nail. So this is the head of the nail. So this is a strong magnet. So I repeatedly rub this nail in this direction. So by dragging this, by touching it, okay, so I touch this magnet, North Pole this here, and I drag it here slowly and then lift it up, okay, lift it up. Always this North Pole goes from this tail of the nail to the head of the nail. So keep doing this many times repeatedly. Then this nail becomes a permanent magnet and this will be its south pole and the head is the south pole and the tail is the north pole. That is how I can make a permanent magnet. Okay. So this iron, when it is magnetized, it will stay as a magnet unless it is heated. If you heat the nail to a high temperature, then the magnetism is lost. Or if you subject it to mechanical shock, if you drop it from a height or if you hit it with a hammer, then again the magnetism is lost. Later, we will also see how to make magnets using electricity. So after we learn about electromagnets, we will see how magnets can be manufactured. Okay, so the next thing we need to know about magnets is about the magnetic field. So we saw that magnetism, that is the force created by magnets, is a non-contact force. It acts as a distance. So for this kind of non-contact forces, scientists imagine an invisible force field in the space surrounding the magnet. So this is a magnet here. So we know that the magnet, when any other magnet is brought in this space, into this area, it gets attracted, it behaves. So the north pole of the magnet is repelled by this, and the south pole is attracted towards this pole. So if I place a small compass needle here, the needle will point in this direction. Okay, so I have drawn these lines of force. These lines are imaginary lines of force. Okay, so I have only drawn a few lines, but at every point in the surroundings, you can imagine the line of force passing through it. So the line of force tells you in which direction a small compass needle will align. So here, near the North Pole, the North Pole will point this way, South Pole will point this way. So this is how the small needle aligns along this line. Okay. So in the space surrounding a magnet, we can imagine a magnetic field. So the magnetic field exists, and these lines, we use these lines to imagine that field. So now let us let's use iron filings, and which will show us this magnetic field visually. So here I have a bar magnet. Okay. That is the North Pole. So I'm placing the bar magnet on the table. Okay. So I'm using this small cardboard boxes to support this sheet of paper, which I'm going to place on top of the magnet. And then I'm pouring iron filings. So this is powder made of iron, very small particles of iron. So I spread them on the paper. Then I tap it with a plastic straw. So as I tap, the iron filings are getting aligned. Okay, they're getting aligned. They're changing the direction, moving slightly, and you can see a pattern appearing, okay, which looks the same as the diagram we drew for lines of force. So this is the pattern which has come out. Okay, so the iron filings have shown us the direction of the magnetic field. Okay, so this is how this is a visualization. It shows you, so that means the field is weak, where the pole is located, where the edge of the magnet is located, there's not much force. And this, you can see those lines of force. So scientists imagine the force field by drawing these lines. So these lines represent the field of the magnet. So we have seen, okay, so before we wind up, let us just See how a bar magnet is stored correctly. So this is how a pair of bar magnets are separated by the black plastic separator, and there are two small plates of iron which are attached at the top. So I'm going to put it back, north pole and south pole, north pole of one, south pole of the other, with the plastic separator in between, and then that small plate of iron stuck to the top. South pole and north pole. So we have seen two things. One is that iron objects become temporary magnets when they are close to to magnets because of induction. And the second thing we have seen is that iron can be made into permanent magnets by rubbing iron objects can be made into permanent magnets by rubbing with strong magnets in proper direction repeatedly. Similarly, cobalt and nickel also can be magnetized. So for now, we take leave of magnets, and we will revisit them in later videos.